Okay, Elon Musk, Peter Diamond's 100 million Xprize carbon removal. Hi, this is Noah Kelper. I recently seen the Elon Musk and Peter Diamond's Xprize competition for $100 million, and I just wanted to see what it would incorporate in order to get 1 gigaton a year of carbon removal from a simple system that just pumps air down into the sea to a pressure where it became liquid and the other gases just escaped, and then the heavier liquid just was either trapped into a container of some sort or left in the deep crevices of the ocean. And these are some of the numbers I came up with. So 1 gigaton is 1,102,311,310.9244 pounds. Or sorry, tons. These are all tons. And so every day you would need to get 3,200,000 tons. Every hour you'd have to get 126 tons every minute, 2,000 tons every second, 35 tons. And then, of course, U.S. tons, 2,000 pounds. This is going as the carbon, or the CO2, carbon dioxide, is 3% of the air. You would have to be able to filter 5,156,367 cubic meters of air through your system. And for some reason, what came to my mind was a pump, an air pump that used gravity and springs. You just put like a weight. You put a spring in here with a weight or a buoy or something. I don't know. In a membrane. This is all just off the top of the head. To make some kind of pump. Pumps air down a tube and to the bottom of the ocean, or located in a certain spot. And you'd have to calculate using a phase diagram for CO2. The best depth and the location for the for most of the gases to go up, and anything that was liquid to stay on the bottom. Or you could have a release valve for gases, and then a containment system for a large containment system for the H2O. I mean, for the CO2. That whether it's collected to pipes you collect or whatnot, whether this is most likely to be a liquid. You'd want this to be a liquid under pressure, under the ocean. This is like the ocean. So back to, so for 1 ton, did I not write this down? I thought I finished this equation. So yeah, so you would have to filter. Hello again. I just had to do a quick calculation that I had thought I had already did. So in order to get to a goal of a gigaton of CO2 emissions by filtering the air and turning the CO2 from the air into liquid and separating it from a liquid form from the gases, you would need to filter per second 180,266,584 cubic meters of air per second in order to end up getting a gigaton, around a gigaton of CO2 emissions out of the atmosphere. That is 10,815,995 or 1,995,040 cubic meters of air per minute. So this system would, or any system that tries to change the atmospheric pressure or temperature to separate the CO2 would need to be able to facilitate moving a tremendous amount of air fluids through the system. That's just one little thing I thought I'd say.